Now let's look at the concept of vertex cover. A vertex cover of a graph is the set Q subset of vertices of G that contains at least one endpoint of every edge. So what I mean by this is, using the vertices you are supposed to cover the edges. So how is it possible? Now if you look at this, okay, see, now, okay, let's take this graph, this example. Now if you look at this graph, if I take this vertex, I'll be able to cover this edge, this edge, this edge, right? And if I take this vertex, I'll be able to cover these two edges. That is how vertex cover is. So what is it? You have to select some vertices in such a way that you cover all the edges. Cover all the edges means that vertex should happen to be one of the endpoints of the edges, right? So one other way of understanding it in a better way is, you can assume that every edge is a road and every vertex is a corner, right? And now you have to make some watchmen stand at the corners in such a way that they will be able to cover all the roads. So if you make a watchman stand here, he will be able to watch this road and this road. If you make a watchman stand here, he will be able to watch this road and this road, right? So that is how you can say, you can think about vertex covering. So using the vertices, we are supposed to cover the edges, right? And it need not be minimal. So whatever cover you get, yes, that is a vertex cover. Only thing is, that contains at least one endpoint. Now if you take this graph, you can even say that I'll take all the vertices and that will be a vertex cover. Yes, true. Or you can say that I'll take this one, this one, this one, this one. Yes, true. Or you can say I'll take only these two. Yes, true. As long as you cover all the edges, you can take any combination of vertices, right? Okay. Now what is the relationship between the vertex cover and the matching is, see this? Since no vertex can cover two edges of the matching, the size of every vertex cover is at least the size of every matching. So they are saying that, see this. Now the size of every vertex cover, let us say vertex cover size. What is size of vertex cover? The number of vertices present in the vertex cover is called as size of the vertex cover. Now in this case, what is size of vertex cover? Since I have taken two vertices, vertex cover size is 2, right? So in this case, what is the number of what is the size of vertex cover? Since I have taken 3, the vertex cover is 3. Got it? Okay. And now they are saying that the size of vertex cover is at least size of every matching. Vertex cover is always greater than or equal to size of the matching. Now why should this be true is, if you take a matching, what does it say? It says that matching is a set of all edges which do not have any vertex in common, right? Therefore it will contain the part of the graph. For example, if you take this this graph, now in this graph the matching is this edge and this edge, isn't it? So one of the matchings is this edge and this edge. Now if you include that matching, right, so these two edges are having completely independent vertices. Now in order to cover only these two edges, you are supposed to take at least two vertices. Forget about covering the other edges. Only to cover the edges which are present in the matrix, you need the vertex cover which will be equal to that matching number, right? Therefore you have to cover all the edges which are present in the matching and also the edges which are not present in the matching. Are you getting this? In order to cover all the edges which are present in the matching, that itself will require a number of vertices which is equal to the matching size. And apart from this, you are supposed to cover the edges which are not there. So in worst case, what happens is, you might end up taking all the one vertex for each edge which is present in the matching and also some other vertices to cover the remaining edges. Therefore vertex cover size is always going to be greater than or equal to matching size, right? So for example, in this one, if you see it, we are lucky that this is the matching, we got 2 as the matching, right? And now if you see this, if I had taken this edge, this vertex and this vertex, it is covering everything, which means vertex cover is also going to be the matching size. But in this example, if you see, this is the matching. I have taken these two, right? Now in order to cover these two edges, you should definitely take two vertices, right? So let us say I have taken these two vertices, right? Then I have to cover these remaining edges as well. For them I have to take one more vertex. Therefore what happens is, a matching is a part of the graph, which means you have to cover all those edges which are present in the matching, and so you have to take one vertex for every edge which is present in the matching. Apart from this, whatever are the remaining edges in the graph, you have to cover them. That is why you have to take few more, in worst case you might have to take few more vertices, and so vertex cover size is always greater than or equal to the matching size in any example, right? So in best case both will be equal. This is the example, right? In worst case vertex cover may be more, right? So let us say you had taken, instead of these two, if you had taken these two, what would have happened? If you had taken these two, see, now this one is covered, this one is covered, this one is covered, this one is covered, but you still will have to cover this one, right? For that reason you might have to take one more vertex from out of these two. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.